blueprint for the floor of a natural history museum is shown. The scale of the museum to the blueprint is 20 yards to 1 inch. Bam! Right? Okay. Hopefully I didn't break your speakers, but guess what just hit us in the face? Our scale. Very important. What is the area of the floor of the actual Great Hall? Okay, so what we just found out, because we reread the problem again, all right, and we found out, here's the important piece of information. The first thing that's important is the fact that, bam, here is our scale. 20 yards in real life is 1 inch on the blueprint. We also know the length is 1 3/4 of an inch and the width is 3/4 of an inch. We also know we're looking for the actual area of the floor. So we know that we're going to have to use this formula to find area. So what I'm going to have you guys do right now, you guys have just 3 minutes. I only want to take 3 minutes of your time. And I want you to try to solve and find the area, the actual area of the Great Hall. So if we look at this, all right, the first question says this: what is the area of the floor of the actual Great Hall? All right, so what you should have done to figure this out, the very first step is you have to find what the actual lengths are. So to do that, hopefully we're back into understanding. I mean, you could absolutely positively use a model to do this, or look at this. 20 yards is to 1 inch. So if the length is 1 3/4 of an inch, we are looking for the actual length. Well, 1 times 1 3/4 gives us that. So therefore, we're going to multiply 20 by the same thing. So it looks like this: 20 times 1 3/4. So I'm going to make this an improper fraction. I'm going to change this. 4 times 1 is 4, plus 3 is 7/4. I'm going to cross simplify, right? So 4 goes into 4 once, 4 goes into 25 times, and I'm going to multiply straight through. So our actual length of the room is 35 yards. Now we're going to do the same thing for the width. So we basically, look what we basically just did. We took our scale and we multiplied it by the drawing. So that's what I'm going to do on this one. 20 times 3/4. So 20 over 1, make that a fraction. Cross simplify and multiply it straight through. So now that I have my length and my width, I'm going to use the formula to find the area, length times width. So 35 yards times 15 yards is equivalent to 525 yards squared. Okay, and I'll come back to that in a second. So what is the area of the floor of the actual Great Hall? Was 525 yards squared. And you guys are writing this in as I go along through it. Okay, all right, so the scale factor means is 20 to 1. That's our scale factor. And what it means is for every 20 yards in the actual distance is 1 inch on the drawing or the blueprint. That is what that scale actually means. So the scale from the museum of the drawing is 20 yards to 1 inch. Another scale from a museum to the drawing is 400 yards squared to 1 inch squared. Explain why. Because if you think about it, if we were to find, if this was like a rectangle, or I mean a square, what we would do is it would be 20 by 20. So 20 times 20 is 400 yards. Oops, oh my goodness, sorry. 400 yards squared, and 1 times 1 is 1, so 1 inch squared. So what this is, it is the actual, it's the area. What we did is we found the area. So that's the scale from the area of it. The area of the Great Hall in blueprint is 1 5/16 of an inch squared. So how they got that is they just multiplied this by this to get this. Why does multiplying the blueprint area by scale factor of 20 not give us the area of the actual floor of the Great Hall? So what happened is this, and I had a lot of people do this this morning. They found the area of this, of the blueprint. And then when they multiplied it by the scale factor, they ended up getting like 100. It was only 100. And the reason why that happened is because if you think about this, sorry, just a second. If you think about, oh, sorry, I dropped my paper. Just a minute, just a minute. You are not multiplying by the scale factor. You have to multiply by the scale factor twice. Okay, so you must, in order to get the 525, you must multiply the blueprint area by the scale factor area twice. Okay, because this would be a 20 by 20 because this is the area, right? So that's why it doesn't work if you did it the other way. Okay, all right, so we're going to skip 5 and 6 on this. So moving on, let's take a peek at number 7 on page 18. We're going to take a peek at number 7 on page 18.
I can't hear you.
Okay, so here we go. Sorry about that. Let's try this one more time. Okay, so bam, right away, I noticed that here is my, this right here is my scale factor, right, or my scale. So every 4 meters is 1 centimeter. The length of the drawing of the playground is 5.3 centimeters. So that's an important piece of information. And the width is 3.8 centimeters. What is the area of the actual playground? So remember, what we have to do first is we have to find the actual dimensions. So to find the actual dimensions, we're going to take our scale factor, which is 4, and we're going to multiply it by both of these. So the first one would be 4 times 5 3/10. And the next one is going to be 4 times 3 8/10. So let's go ahead and have you guys write this down with me as I go through it. Okay, so I'm going to go 4 times 5 3/10. And so the length of the playground is 21 2/10 meters. Okay, all right, and then we go 4 times 3 8/10. So the width comes out to be 15 2/10 of a meter. Now we look at the shape because we have to find the area. This is a rectangle, so I'm going to use length times width. So area is 21.2 meters times 15.2 meters. And we find out that the area of that comes out to be 322 and 24 hundredths. So the actual area is 322 and 24 hundredths meters squared. 322, sorry, my decimal point got a little bit lost right there, meters squared. Okay, all right. And I will come back, I will ask you for questions in 1 second. All right, next. Now, number 8 does get a little bit tricky. And I know if I'm going too fast, I will keep this up for you guys so you can finish the notes on it in a minute. Okay, so here we go. A square has an area of 140 feet squared. I have to draw this out just so I have a visual because it helps me out. So that's the area of that square. I don't have room to put the feet squared. I know it's in there. In a scale drawing of the square, so here's my scale drawing of the square, each inch represents 6 feet. So 6 feet is to 1 inch. What is the area of the square of this drawing? So I need to find this area of the square. Now here's where it gets a little bit tricky, okay, because they don't give us dimensions. They're looking for the total area of this. And what we have to compare it to is this right here, okay? So we know that this is 144 feet squared. We also know that each inch is 6 feet. Well, in order to be able to compare these and get like a scale factor, this has to be in area form. So what we have to do is we're going to go 6 feet times 6 feet, which comes out to be 36 feet squared to 1 inch times 1 inch is 1 inch squared. Okay. So now that I have this broken down into area, all right, with this scale, all I'm going to do now is to find the area of this. I am going to divide 144 divided by 36, and it comes out to be 4. So this right here, and I know this is a confusing one, and I can go back and revisit it as soon as I'm done. But the area of this is 4 inches squared. So that's the drawing. Okay, so this problem right here is very similar to what we talked about on number 4 right here. All right, about multiplying the scale factor twice. Okay. Okay, and last but certainly not least, below is a scale drawing of the side of a ramp at a skateboard park. The scale from the drawing to the actual ramp is 2 centimeters to 12 inches. Bam! 2 centimeters to 12 inches. Or the other way to write it is 12 inches to 2 centimeters, which reduces down to 6 to 1. So here's my scale. What is the area of the actual side of the ramp? All right, so the very first step that we have to do is we have to change these from what they are in on the drawing to the actual. So we're going to set it up. If that's my scale, I'm going to go 6 times 2, which is 12. And then I'm going to go, keep muted, please. All right. And then I'm going to go 6 times 8, which is 48. Okay. This is my scale right here. This is my side, and this is my side. So now that I have that, I need to find the area. This shape is a triangle. So area equals 1/2 times base times height. That's the formula to find the area of a triangle. So all you're going to do is plug it in. So 1/2 times my base was this, in actual length it's that, 48, and it is in inches, times my height, which is this, 12 inches. So 1/2 of 48 is 24 inches times 12 inches. And all we're going to do is multiply those together to get 24 times 12. So my area is 288 inches squared. Okay. All right.